Okay, so how do you choose then between the sanitizing agents that you would be using for biofilm, algae, and pathogen control? Well, let's run through some of those different options. Cost is one obviously important aspect, but it's not the only one, because the efficacy of these different treatments will vary depending on the application. Filtration underlies all of these sanitizing agent chemicals. The cost here, the installation cost, 1 star represents less than $2,000 for a 5-acre greenhouse or nursery. 3 stars represents more than $10,000, and the operation cost is based on a cost per 1,000 gallons, and it's a relative measure. So the cost of filtration varies depending on how fine a filtration you want to go to. Typically, we're talking about disc or media filters that are taking out the chunks of organic material. But this can go all the way through to reverse osmosis, which are fine enough to be removing pathogen spores. Chlorine comes in 3 different forms. Gas chlorine is the cheapest source of chlorine, followed by sodium hypochlorite, which we commonly call bleach, followed by calcium hypochlorite. All of these are fairly cheap to use on a per 1,000 gallon basis, and often have a very simple injection system. What many growers do not appreciate is that the effectiveness of chlorine is very pH dependent, as we saw in that graph earlier. So the installation cost could be very low with a simple injector, or for it to be a more effective, more controlled system, there's also pH control of the water and measurement of oxidation reduction potential, ORP, as part of the control system. So that's going to lead to a more safe and effective system and using less active ingredient by having a better control. Chlorine dioxide can be provided either through one tank, where it's a simple stock solution that's put through a chemical resistant injector. That is very low cost to install, simple injection system, but it's one of the more expensive options in terms of per 1,000 gallons. Another option is to have a 2 or 3 tank system on site. Whatever form of chlorine dioxide injection you have, the chlorine dioxide gas is generated at the nursery. So one option is to have 2 or 3 tanks of chemicals that are mixed, and chlorine dioxide is generated, and that reduces the operating cost. The reason the installation cost can be low is because some of the companies will provide the equipment for making chlorine dioxide on a lease basis. Copper ionization has got a fairly high installation cost, but it has a very low operating cost per 1,000 gallons. This is used by a lot of plug and liner growers because it doesn't cause oxidation of any of the equipment, and is a very effective technology for suppressing algae and controlling pathogens. Activated peroxygen products include Xeritol, Xeriton 3, Sanidate 12.0. These products, again, are low installation cost but have a higher per 1,000 gallon cost. Hypochlorous acid is the active ingredient, and chlorine is a product called Oxide, which is a refined version, stabilized version of hypochlorous acid. Low installation cost, moderate operating cost. Ozone falls into a similar category to copper ionization, greater upfront cost, but a low operating cost per 1,000 gallons. And it's starting to be used in some large operations and is a very effective oxidizer. You're going to hear more about slow sand filtration in constructed wetlands when you hear from Dr. Oakey and Sarah White, Dr. White, later on in the series. And UV light differs from these other technologies in that it's a point treatment, and so it has no residual effect Now, water treatment systems, we can look at them in terms of cost, but you as a grower are going to have to figure out how to work this into your system. And one of the challenges is that the treatments vary in their complexity. We're trained to grow plants, but water treatment technology's got lots of moving parts, or some complex water chemistry and so on. So to take on one of these water treatment technologies successfully, you need to do some research, do maintenance, and there's a certain advantage in either picking something simple that you're going to do yourself, or have an expert from industry do it for you. So chemicals that are dosed with a simple injector or copper ionization, there's really, it's quite realistic for a grower to do their own on-site maintenance and monitoring. However, if it's a more complex system, that's not necessarily a bad thing, but it does mean that unless you've got a very, very good person with a strong engineering or chemistry knowledge, then it's worth thinking about a service or lease agreement with a company that's supplying that technology, because otherwise you're going to spend high investment cost, and that equipment is eventually going to be mothballed when your one employee who knows how it works leaves the operation. I don't have time to talk about all of the technologies, but here's an example of some research on chlorine, which is the most widely researched sanitizer. And this is some work that was done at several different universities. What these plant pathologists found was that 2 parts per million of free chlorine is enough to kill the zoospores, the swimming infective spores, of the water molds Pythium and Phytophthora. Contact time is less important at 2 parts per million, but as the active ingredient level goes down, the contact time becomes more and more important. Some growers will therefore have a settling area after injection to increase contact time. There are certain life stages that are more resistant to sanitation. So, for example, mycelial fragments, the threads, fungal threads of Phytophthora, require a higher concentration for control. There are also other pathogenic species that have even more resistance to control from a sanitizer. And we need to put this in perspective of the risk of phytotoxicity as well as worker safety. So, for example, work at University of Guelph found that 5 parts per million of free chlorine caused phytotoxicity on woody ornamentals. And talking with growers, there are certain crops such as sea geraniums that are much more sensitive, down at 1 to 2 parts per million of free chlorine. Here's an example of some research from Colorado State University on chlorine. We're looking at free chlorine parts per million from 0.125 up to 2 parts. And in this experiment, they varied the pH of the water, which I keep coming back to as being very important for chlorine, where either it was acidified to 6.2 to 6.6, or the pH was a higher level. And the mortality of a couple of different Pythium species, in this case Pythium aphanidermatum, zoospores, were measured with different contact times, in this case 2 minutes. What you can see is that there was much more mortality at a low free parts per million of free chlorine when the pH was low. And that's because the chlorine is in this hypochlorous acid form. Another interesting thing in this research was they measured this ORP, oxidation reduction potential, in millivolts. And what they saw here was that there was a need for an ORP level somewhere above 700 millivolts to get adequate control of Pythium aphanidermatum. The reason this ORP is very useful is that's a sensor that can be put in line for control, or it can be a handheld sensor that you can go out and test your chlorine parts per million, your pH, and your ORP. So when it comes to disease management, the parts per million that we need is specific to the control agent, whether it's copper or chlorine, chlorine dioxide, the pathogen, for for example, Pythium versus Fusarium, the life stage, such as Canidia or zoospores, and other factors such as contact time and pH. We're currently writing down a literature review of efficacy tests of the published work that's out there with the different sanitizers, and that'll be available to growers next year in 2011. But there's definitely more efficacy, residual, and phytotoxicity research that's needed and is underway by plant pathologists. You can see from some of that information just on chlorine that you shouldn't rely on water treatment as your sole source of disease management. What we can achieve is to clean up the water source so it's not a source or distribution system for pathogens. But for pathogen control, we need to consider all possible sources of where pathogens may be entering the system, whether it's through dirty used trays, plant material on cuttings, in the growing media, as well as in the water. And when we think about our disease triangle, we also need to think about the environment. We can clean up our water source with a sanitizer, but if we're over-irrigating, creating a really good environment for root rot pathogens, for example, then we can get Pythium infection even if we have a sanitizer in place.